Okay, ladies and gentlemen, this is video number 4 for Algebra 2, finishing up the properties of logarithms notes. Here on the screen, once again, you'll see the properties of logarithms that we're working with. Those are the product rule, the quotient rule, the power rule, and the bin rule for converting between exponential and logarithmic forms. We will not use the bin rule as much in this particular video, as this video will cover how to solve logarithmic equations when there is a logarithm on both sides. In other words, we're looking at slide 11, slide 13, and slide 14 of the set of notes that we are trying to finish. So here is slide 11. We're going to start by solving this equation. You'll notice it has a logarithm on each side. That makes this problem significantly easier to solve than the ones we did in the previous video. We do, however, need to get it to the point where there's only one logarithm on each side. So we're going to do what we've been doing the last several videos, and that is combine each side down to a single logarithm. So on the right side, we are going to multiply 27 and 3 because of the addition symbol here. That tells us to use our product rule. So on the right side, we would have log base 7 of 27 times 3, which is 81. On the other side, we have to take the 2 and use our power rule to place it up on x squared as an exponent. So on that side, we would have log base 7 of x squared. Now at this point we have one logarithm on each side. Those logarithms were both base 7 logarithms. What that allows us to do is state that we can just basically drop those logarithms. That means that x squared has to equal 81. That is an equation we have solved many times before. We would solve that by taking the square root of each side. And the square root of 81 is plus or minus 9, which means x is either 9 or negative 9. We do need to check both of these values in the original equation to make sure that they work. So for this value, we would have 2 log base 7 of negative 9 equals log base 7 of 27 plus log base 7 of 3. And right away, we have a problem there. We cannot have a logarithm of a negative number. So that means we would not use x equals negative 9. That is an extraneous solution, and we would simply pretend that we never saw that one. The other one we check. We have there, for this one, 2 log base 7 of 9 equals log base 7 of 27 plus log base 7 of 3. Just like we did in the original problem, we're going to use the product rule here and the power rule here to give us log base 7 of 9 squared equals log base 7 of 81. And since 9 squared is 81, the two sides of this equation are equal, so our answer would be x equals 9. That equation has only one solution. Now we'll skip ahead to the second to last slide in the notes, which contains our next problem that has a logarithm on each side. Similar problem type. We're going to take the same basic approach. We have two logarithms on the left side. We need to combine those. So if we look closely, we'll see the subtraction symbol in between those two. That means we're going to set up the quotient rule to change this into log base 4 of 48 over x equals log base 4 of 6. Now once we get to this point, we have there two different logarithms, both of which are base 4. So just like we did before, we can drop those logarithms because in order for those two logarithms to be equal, the numbers on the inside of those logarithms must be equal. So that gives us the equation 48 over x equals 6. We would then multiply both sides of that equation by x, which would give us 48 equals 6x, and then we would divide by 6, to give us x equals 8. We do need to check that value, so just real quickly we plug that back in and make sure that everything is going to work in that equation. Quotient rule allows us to combine the left side into 48 divided by 8, which means both sides of that equation are equivalent to log base 4 of 6, which means that is a true statement, and x equals 8 is our solution. Our last slide of the notes contains one more additional problem like the ones we've been working. So here's the final slide of the notes. This one is only complicated by the fact that we need to reach back into our previous section to remember what to do with a fractional exponent, because our first step here is to move this 1/3 up and make it an exponent on 27. So we have here log base 2 of x equals log base 2 of 27 to the 1/3 power plus log base 2 of 36. Now remember that 27 to the 1/3 power is the cube root of 27. So this value here, 27 to the 1/3 power, is 3. So that would be log base 2 of 3 plus log base 2 of 36. Then we would combine these two using the product rule, because again we have addition here, which means we can multiply 3 times 36, which would give us log base 2 of x equals log base 2 of 108. Shouldn't be an equal sign there. Log base 2 of 108. Once again, once we get it to the point where we have one logarithm on each side, as long as those logarithms have the same base, they can be dropped, which gives us x equals 108 as the number that we need to check. So then we check that value. We say log base 2 of 108 equals 1/3 log base 2 of 27 plus log base 2 of 36. First several steps are exactly the same. We move the 1/3 up to make that log base 2 of 27 to the 1/3 power plus log base 2 of 36. We do the 1/3 power of 27, which again is 3. And then we use the product rule to do 3 times 36, giving us that both sides of that equation are equivalent to log base 2 of 108, meaning it does work, and x equals 108 is our answer. Now this completes the notes that we were left in the middle of when all this excitement started. Please keep in mind that you have an IXL assignment due on Friday. Actually, let me check the date on that. We'll check Google Classroom for a due date on the IXL. Again, there are 2 Algebra 2 IXL topics due. Both need to be at least a score of 60 to be considered complete and 80 to be considered a 100%. If you have any questions, email me. I'm happy to work through whatever questions you have. Remember, I will be available during regular school hours at my school email.